So in 2004, these two people from USC proposed a new idea in this conference. This is Parallel and Distributed Processing Symposium. It actually combines two different conferences in this conference. I have attended two of these conferences. One is IPPS, the other is called ID something, and I attended IPPS twice before, but they combined. So parallel and distributed area. So the title of the paper was an adaptive energy efficient low latency map for data gathering in wireless sensor network. The idea is, even if you employ this duty cycling, if you are smart, if you arrange this sensor node in a pipeline fashion so that their wake-up period can overlap in a certain way, then you don't have to experience this delay, sleep delay. You can actually send this information as soon as the event is detected. And he named this as staggered wake-up. Staggered wake-up. The idea is quite simple, but it is a very interesting idea. And this actually activates research in sensor network, and he creates a new area called wake-up scheduling. Okay? So the idea is like this. You wake up and sleep, and you wake up and sleep. Right? Like a little different. In each wake-up period, you have RX and TX. Right? Before you just have RX. If there is any communication, then we can extend for TX. Otherwise, we go back to sleep. But it's RX and TX. So you employ duty cycling. Assume that all the sensors are stationary. They are not moving. And you can organize sensor network in a tree structure. So you have a root, which is a sink, and all the other nodes are descendants of this tree. Okay? From the tree, you organize the wake-up period level by level in this pipeline fashion. Okay? And then this TX period is overlapped with RX period with its parent, and the TX period of this node is overlapped with the RX period of its parent, and so on. So as soon as you detect an event, you can transmit and you can receive without one-hop delay, without cycle time delay. And then as soon as it's received, it's transmit again and received. So if you pipeline this way, then even if the distance is quite far, you can send this information without any delay, right? From the leaf to the sink. This is called staggered wake-up. You skew the wake-up period of each node in the path from a source to a sink. Assume you have these three topologies starting from the sink as a root, and the wake-up schedule of each node is determined by the level of the node in the tree. Okay? And then you can transmit, and you can use this wake-up scheduling for real-time sensor network application. This is very simple and effective. Okay? Very effective. And as I said, this motivates research in this new area, wake-up scheduling. These people from Stanford did, okay, let's find out what kind of wake-up scheduling patterns you can employ to utilize this DMAX idea. And he published this paper in MobiHawk, which is one of top conferences in this area, Mobile Ad Hoc Conference, in 2006. And they look at some different patterns, how we can organize this wake-up schedule in different ways, and how it affects the delay. And he first looked at the SMAC. SMAC, he called it fully synchronized wake-up pattern. So every node wake up at the same time, which is SMAC, and maybe AMAX are close to SMAC in a way, right? Even though they have employed variable duty cycles. So if you look at SMAC, they wake up at the same time and they go back to sleep, wake up at the same time, then they go back to sleep, and so on. So in this kind of pattern, let's say this sync node detects some event and it's trying to send information to a maybe node at the level 3. Okay? So it detects an event, it has to wait on average maybe 1/2 of this cycle time. Right? And then maybe 1, 2, 3 hops. 2 hops, right? 2 hops plus half. So in general, if the distance is 3 hops or number of hops, then the delay is number of hops minus 0.5 because the first delay will be only 0.5 cycle time. The other is full cycle time. Times cycle time is the delay that you experience for this wake-up pattern. Okay? So he did this simple study. And he did other combination, maybe let's wake up even an odd. Okay? So these nodes are odd levels are wake up at maybe regular time or odd times. Nodes at 0, 2, 4, these even levels are wake up at even time or something like that. So they are then even 0, 2, 4 or 1, 3, 5 and so on. And if you detect an event and then you want to transmit from source to a sink, then in this case number of hops is 1, 2, 3. The first one experience if you detect the event 0.5. So 0.5 and 1, 2, 3. So in general, the delay is 0.5 times number of hops times t. Okay, so here the actual delay is each hop you experience half of the cycle time. So he drew this figure in a strange way, but in general, you detect the event and you have to wait until the second your parent wake up. And the delay, the first hop delay you will experience is only 0.5 cycle time because you detect the event and half cycle time, maybe the parent will wake up. Okay? So 0.5, 0.5, 0.5, so in this case 0.5 times 3. Okay? In general, if your distance is h, then h times 0.5 times t. T is the cycle time. But his figures are somewhat misleading, right? Because if you think about carefully, do not consider this. You detect the event, okay? And then you wait until the next hop, your parent wake up. You will experience 0.5 cycle time. Agreed? That's the first hop. From the second hop, you experience 0.5, 0.5. So 0. Times 3. Okay? So if the distance is h hops, then you should experience 0. Times h times and the cycle time, right? That's the delay. Their figures are always a little bit misleading. Let me explain. I think you should understand this. Okay, let's look at the other. DMAC. And DMAC, in the DMAC paper, they call it staggered wake up, but the people from Stanford, they call it ladder pattern. Ladder is, the ladder, right? Ladder pattern. So you squeeze the wake up period of node in the communication path, and so here, let's say you are sending this information from sink to the node at level 3. Level 3. This figure is somewhat also misleading, but in general, if you look at this wake up period should be something like this. Something like this. And the DMAC is like pipeline from here to here. Right? Here to here. Here to here. But instead, he drew something strange. He didn't draw this wake up period at this point. Instead, he moved a little bit So that it's a little bit confusing. But you imagine the wake-up period should be here, and then one cycle. Okay? Okay, and this is called staggered wake-up or ladder pattern. But if you do this, then it will lead to asymmetry, because if you make it in a pipeline way from sink to the sink to the leaf, then this direction will send the information very fast without incurring any delay, because you already schedule your wake-up scheduling. But the other direction will be very slow, right? Because they didn't consider they consider only one direction for pipeline delivery. Okay? So the other direction is something like irregular, but this figure is misleading. You have to draw like this, and diagonal drawing is most like this. It will be slower. Okay? That's the actual figure. Okay? No further explanation. Okay? That's the ladder pattern. And he did some combination of this ladder pattern. So this is called two ladders pattern. So this is also somewhat misleading. What he wants to show is you can do in this way, ladder pattern. But somewhat not coincide in this figure. It's two ladder patterns are not matching well, so it's somewhat misleading, but in this way. So by doing this two ladder pattern, you can improve the delay in both directions. Okay, because you pipeline wake-up scheduling of nodes from sink to the root, sink to the leaf, and leaf to the sink. Okay, so you can combine the forward ladder with the backward ladder, and you can employ this kind of cross ladder patterns also. Cross ladder means, so the previous one is like this. Cross ladder is like this. Okay? So here what he suggests is the first one you cross two ladders at level 1. So here he tried to cross at level 1 here. Okay? So this one and this one. Okay? And level 2 should be like this. You should cross at this level, something like that. Okay? And level H minus 1 is like, if this is the leaf, it should cross at this point. Okay? And so on. So he did window 1, starting from window 1 to window H minus 1, so that this cross ladder is happening uniformly across this tree in different levels. Okay? So that they consume the same amount of power. So what he's suggesting is a little bit of optimization. So when you wake up, so they wake up twice, and then you can transmit once in the down direction, another one for the upward direction. Okay? Then they can optimize a little bit further. And they call it cross ladder pattern. Very simple pattern. Okay? And this is called cross ladder pattern. And finally, what he proposed is this might be the best, which is not a new idea, but it combines two different trees in a sensor network. So this is the root. Starting from the root, you can organize tree, maybe two different trees or three different trees. So the tree is the same tree, data gathering tree as DMAX suggests. You can have this tree, you can embed this tree, you can embed multiple trees in the same sensor network, starting from the same root. Okay? And he called one is red tree, the other is blue tree. And both of them have this wake-up scheduling employed, and so you can transmit event in a pipeline fashion. But sometimes when you detect event, you have to wait until the next one, your parent wake up. But if you have two trees, then sometimes you have two options, so you don't have to wake up for the other. If some tree has wake-up scheduling coming early, then you can use this wake-up scheduling instead of the other one. So that's the advantage of having multiple trees in this multi-parent method. Okay, so only a little bit of improvement. Okay, so they suggest a different combination, but in my opinion, most of them are actually not new. Okay, it's just using DMAX idea, and he did some analysis. That's why his paper is presented to the MOVIHA. Okay, so each node has multiple paths, multiple parents to the sink. So depending on the packet arrival time, the node can choose the fastest path to get to the destination, obviously. Okay, so that's their study wake-up scheduling. So